Okay, so these are called quartiles because we're basically splitting up the data into 5 groups. Now, we only have a small amount of numbers, so this is more significant when you got a lot more data. But we don't need to do this with 200 numbers to get the idea. This is called the lower quartile. This is called the upper quartile. And this is called the median. Now, mathematicians like to use fancy symbols and subscripts. So since these are called quartiles, mathematicians use the letter Q. So the lower quartile would be called Q1, the median would be called Q2, and the upper quartile would be called Q3. So mathematicians will use subscripts. Okay, so since this is symmetrical, you know, we're going to have the median, the middle number, the same as the mean. When it's not symmetrical, these two are different. Now, how do you get the standard deviation? The standard deviation gives you a number to give you the spread of data. On average, how far are the data values away from the mean? Now, we always base it upon the mean, not the median. Okay, so you have your bunch of numbers, there's 10 of them. What we want to do is calculate how far the data values are from the mean. So we're going to subtract each data value from the mean. Now, when we do that, some of these are going to become positive and some of these are going to become negative. That's an issue, because if we want to find the average distance from the mean, we're going to have to add all these numbers and then divide by 10. But if we got positives and negatives, when we add them, we might wind up with 0. 0 divided by 10, that's the average distance. That's obviously illogical. So what we do to compensate is we square this subtraction. That way these are all positives. Then we can add them up and divide by 10. And then since we squared to deal with the positive negative issue, once we subtract from the mean, square them, add them up, divide by 10, we take the square root to compensate for why we squared them. So you're going to get 1 minus 5.5 squared, 2 minus 5.5 squared, 3 minus 5.5 squared, and so forth. And then once you do that, this will become 20.25, 12.25, 6.25, 0.25. Oh, wait, I think I skipped something. Yeah, 2.25. So I'll just write them down. This is what you should be getting after you subtract and square. No, wait, I think I forgot one too, did I? Oh, this is also 0.25. Okay, and these are always going to be positive, and then you take the sum of those numbers, okay, and then you divide by 10, because there's 10, and then you take the square root, because we're compensating for having to square the numbers so we can avoid the positive negative issue. And this is called the standard deviation. And it should be between 2 and 3. So I'll just tell you it's in between 2 and 3. So if you make a really goofy mistake, you can go back and check. And it might be something goofy you did here. Now in statistics, we do a whole lot more with this, but we're not going to go there as much as I like to, because I love statistics. It's kind of fun. I find it fun. It's not something that is part of this class. Okay. Now I just kind of showed you what you should be getting, but again, the data value minus the mean squared. So I set that up a little bit. Same thing down here. Now, because this is symmetrical, notice you're getting the same results below as you're getting above. And again, once you subtract from the 5.5 and square, these are the numbers you should be getting. Then you add those 10 numbers up. That's the sum after you subtract from the mean and square. That sum divide by 10 because there's 10 numbers. And then because we squared this subtraction, so these are always positive, we then compensate for that by square rooting after we divide by 10. And it's called the standard deviation, and it should be something between 2 and 3.